Hello and welcome to you. If you're getting ready for your WAEC, NECO or JAMB exams, then you are in exactly the right place. Today, we're diving deep into a topic that is, and I mean this, absolutely essential for your success: metals and their compounds. This is one of those areas that pops up every single year, so getting a solid grip on it is going to give your score a serious boost. Let's get right into it. Okay, so here's our game plan for today. First, we'll quickly look at why this topic is so important according to your official syllabus. Then, we're going to build our foundation, looking at the properties of metals and focusing on groups 1 and 2. After that, we tackle the heavyweights, transition metals, how we extract them, and alloys. And here's the best part. We're going to solve real past questions from WAEC, NECO, and JAMB together. And finally, I'll arm you with the key formulas and tips to absolutely smash any question that comes your way on metals. So, you might be wondering, why the big focus on metals? It's simple, really. They make up over 75% of all the known elements on the periodic table. They are literally everywhere and in everything we use. And because of this, you can bet your examiners for WAEC, NECO, and JAMB love, and I mean love, to test your understanding of them, from their basic properties all the way to their big industrial uses. And let me be very clear about this. Everything we are going to cover today is pulled straight from your official exam syllabus. We're not wasting any time on stuff you don't need. We are laser focused on exactly what the examiners expect you to know: the general properties, the key things about alkali and alkaline earth metals, the industrial giants like iron and aluminium, and of course, alloys. This should give you confidence that you are studying exactly the right things. Okay, let's dive right in. We're going to start with the fundamentals. Before we can talk about specific metals like sodium or iron, we need to be crystal clear on what makes a metal, well, a metal. So let's break down their core properties. Right, when we talk properties, it's always good to split them into two camps: physical and chemical. Physically, you know this stuff already. Metals are strong. They are malleable, which means you can hammer them into thin sheets, and they are ductile, meaning you can pull them into wires. They are also fantastic conductors of heat and electricity, and they have that signature shiny look, which we call luster. Now, chemically, and this is super important, so listen up. The number one thing about metals is that they tend to lose electrons to form positive ions, which we call cations. They also typically react with oxygen to form basic oxides. Let's zoom in on our first specific metal, a group 1 superstar, sodium. It's incredibly reactive. For your exams, you absolutely must know how it's extracted. It's done by the electrolysis of molten sodium chloride in something called the Downs cell. Also, Solvay process is a huge favorite of examiners. It's the industrial method for making sodium carbonate, washing soda. And of course, sodium hydroxide or caustic soda is the backbone of the entire soap-making industry. And that brings us perfectly to our first calculation. This is a classic electrolysis problem, exactly the type JAMB loves to throw at students. They give you the current, the time, and all the constants you need. Your job is to find the mass of the metal produced. Now, don't panic when you see numbers. It's just a simple 3-step process. Let's break it down together. Okay, let's solve this thing. Step 1. Find the total quantity of charge, Q. The formula is simple. Current, I, times time, T. So that's 5 amps multiplied by 1,932 seconds, which gives us 9,650 coulombs. Easy, right? Step 2. We need to convert this charge into moles of electrons using Faraday's law. So we divide our charge 9650 by the constant 96500, and that gives us a nice round 0.1 moles of electrons. Finally, step 3. From the half equation, Na plus plus an electron gives you Na. The mole ratio is 1:1, so we also have 0.1 moles of sodium. To get the mass, we multiply the moles by the molar mass. 0.1 times 23 gives us our final answer, 2.3 grams. See? Not so tough, right? Let's hop over to group 2 now and talk about calcium. For your exams, the most important source you need to know is limestone, which chemically is just calcium carbonate. Now, when you heat limestone really strongly, that process is called thermal decomposition. It breaks down into calcium oxide, which has the common name quicklime, and carbon dioxide gas. If you then take that quicklime and add water to it, you get calcium hydroxide or slicked lime. This whole process is vital for the Nigerian construction industry because slicked lime is a key ingredient in making cement and mortar. All right, time for another calculation. This one is all about stoichiometry, a skill you absolutely must have for your theory papers. The question is based on that decomposition of limestone we just talked about. We're given the mass of calcium carbonate and asked to find the volume of carbon dioxide produced at STP. Again, don't worry, we just follow the steps. First things first, in stoichiometry, we almost always need the molar mass. For CaCO3, that's 40 for calcium, plus 12 for carbon, plus 3 times 16 for oxygen, which gives us a very convenient 100 grams per mole. Step 2. Let's find the number of moles of CaCO3 we started with. That's mass over molar mass, so 25 divided by 100, which is 0.25 moles. Now look at the balanced equation. CaCO3 gives CaO plus CO2. The mole ratio between the reactant and the CO2 is 1:1, so we also have 0.25 moles of CO2. Finally, step 3. To get the volume at STP, we multiply the moles by the molar volume, which is a constant, 22.4 dm cubed. So, 0.25 times 22.4 gives us our final answer, 5.6 dm cubed. Perfect. Now that we've nailed the basics with groups 1 and 2, let's move on to the big boys of the periodic table, the transition metals. These are the real workhorses of industry. Metals like iron, copper, and of course, aluminium. Understanding these is not just key to understanding our modern world, but also to scoring really high in your exams.
Even though aluminium is more reactive than iron, it doesn't rust away. Why? Because it forms a thin, tough, non-porous protective layer of aluminium oxide that stops any further reaction. Iron's oxide, rust, is flaky and porous, so it just falls off and lets the metal keep corroding. You must remember this difference. So what in the world is an alloy? Well, it's simply a mixture of metals or a metal mixed with another element. We make alloys to give them better properties, like making them stronger or more resistant to rust. This table right here shows the 4 alloys you absolutely must know for your exams. Brass is copper plus zinc. Bronze is copper plus tin. Steel is mainly iron and carbon. And duralumin is aluminium and copper. I'm telling you, their compositions are easy marks in the objective section. So please memorize them. All right. This is the moment you've all been waiting for. We have covered the theory, we've done the heavy lifting. Now let's put that knowledge to the test. We are going to tackle real, actual past questions from WAEC, NECO, and JAMB. This is how you build true exam confidence. Let's see how you can apply everything we've just learned. Here we go. Our first one, a WAEC theory question from 2016. It's a very direct question. No tricks. It's asking for 2 differences between metals and non-metals for both physical and chemical properties. This question takes us right back to the very beginning of our lesson today. It's a test of fundamental knowledge. So, how would you answer this to make sure you get every single mark? So, The most important thing here is to make a direct comparison. For physical properties, you can say metals are malleable and ductile, while non-metals are brittle. For chemical properties, metals lose electrons to form positive ions, whereas non-metals tend to gain electrons to form negative ions. That exam tip is crucial. Don't just list properties for each one separately. You have to use comparison words like while or whereas to show the examiner you are directly comparing them. That is how you score maximum marks. Now, for a JAMB question from 2009. This is a classic test of your knowledge of periodic trends. It's asking, which of these metals will show the highest metallic character? Our options are zinc, copper, barium, and calcium. Now, this is not a guessing game. There's a clear chemical principle that will lead you straight to the answer. Do you remember the trend for metallic character? The key concept is simple. Metallic character increases as you go down a group in the periodic table. Why? Well, as you go down, the atoms get bigger, the outermost electron is further from the nucleus, and it's easier to remove. So, if we look at our options, both calcium and barium are in group 2. But barium is below calcium in that group. That means it loses its electrons most easily, making it the most metallic of the choices. So the correct answer is C, barium. And finally, let's look at a NECO question from 2009. This is an excellent reasoning question that directly tests that special property of aluminium we discussed. It says, aluminium is more reactive than iron, yet it doesn't corrode as much. Why is that? The options might try to confuse you, but if you remember what we talked about, the answer is very straightforward. The key concept here has a special name. It's called passivation. The moment aluminium is exposed to the air, it instantly reacts to form a very, very thin but very tough and non-porous layer of aluminium oxide that acts like a shield, sealing the metal underneath from any further attack by air or water. That protective layer is why the correct answer is D. This concept of passivation is a high scoring point, so make sure you understand it very well. We have covered so much ground today. We've gone from basic properties all the way to industrial processes, and we've solved real exam questions. Now, let's put it all together. Let's consolidate everything you need to lock in that A1 grade. Okay, listen very well. We have covered so much ground today. We've gone from basic properties all the way to industrial processes, and we've solved real exam questions. Now, let's put it all together. Let's consolidate everything you need to lock in that A1 grade. Okay, listen up. These tips are golden. Number 1, memorize the reactivity series. It is your key to predicting displacement reactions. Number 2, know your alloys and your compositions. I'm telling you, those are bonus marks just waiting for you in the objectives. 3, practice your calculations on electrolysis and stoichiometry until you can do them in your sleep. And finally, a very common mistake students make. Do not confuse the extraction methods. The very reactive metals like sodium and aluminium need powerful electrolysis. The less reactive ones like iron can be extracted by simple reduction with carbon. Get that right. And that is a wrap on metals and their compounds. I really want you to leave this lesson feeling empowered and confident. You are more than capable of understanding this topic inside and out and absolutely smashing your exams. Keep practicing, stay focused on your goals, and most importantly, believe in your ability to succeed. You've got this. If you found this lesson helpful, please like this video, share it with your classmates and friends who are also preparing for WAEC, NECO, and JAMB, and subscribe to our YouTube channel right now so you don't miss the next topic. Also visit www.examkp.com for thousands of free practice questions and answers. Let's smash these exams together!